In this example, we will be graphing two functions, and I'm telling you that they are inverse functions. Okie doke. Let's start over here with this one. This one's easier. We're familiar with this, or we should be. This is an exponential function. I'm going to say that it's modeling exponential growth. How do I know that? Because I'm so smart. Well, the base is bigger than 1, so that means it's increasing or growing. Now, I'm going to just start a little table of values here. I'm going to plug in some numbers, see where this goes. You should know the initial value here is 1, but just to confirm that, well, 2 to the 0 is 1. How about 2 to the 1? 2. 2 to the 2? 4. Look at that exponential growth. 2 to the 3? 8. Way up there somewhere. Let's do a negative to stay balanced here. 2 to the negative 1 is 1 over 2, or 1/2. So, we've got exponential growth. Looks good. Now, what is this log function going to look like? Well, notice that this is also in base 2. We've got a base of 2 over here as well. But this is a log function. Now, log functions are supposedly inverses of exponentials. And we'll see why that is in just a moment. But let's just make a table of values here. And let's be strategic in our choosing of numbers. Let's start with an easy number, 2. Why is that an easy number? Well, log base 2 of 2. Let's think about that for a second. 2 to what power gives us 2? The answer is 1. So there's your log. Y is always the log base 2 of whatever number you have for x. Let's try another number. 3 probably wouldn't be a good idea because I don't know what power would give me 3, but I do know 4. Log base 2 of 4, well, 2 to what power gives us 4? Answer is 2. Next number that might be wise to choose would be 8, because log base 2 of 8, 2 to what power gives us 8? The answer is 3. Now, we can get some other numbers here. Here, let me show you one that would be another wise choice, 1/2. Log base 2 of 1/2. 2 to what power gives us 1/2? Well, that's a fraction, so it's got to be a negative power. Well, it's just a plain old 2 down there, so that must be the first power. A negative 1 power, we'll say, to make it a fraction. So let's plot these points and see what we get. I'm going to make these stars in my graph, because the log is the star of the day. So 2, 1 is my first point. 4, 2. 8, 3. 5, 6, 7, 8, 3. Interesting. 1/2, negative 1. So if I connect these stars, I'm going to see an inverse graph. Well, how do I know this is an inverse? Let's remember, ladies and gentlemen, that inverse functions are reflections of one another over this lovely line, y equals x. And you can see that, I hope, here, if my pen would work. There we go. The line y equals x is the mirror of these two functions, of this exponential function and this log function. Now, I'm just going to point out one quick characteristic of this log function that kind of carries over from the exponential function. Remember, the exponential function had a horizontal asymptote that it didn't cross. It approached 0 but never crossed it. We have the same thing happening here with the logs, but we're kind of flipping it and reversing it. So what are we calling this? This will be an asymptote, but in the log function it's going to be a vertical asymptote. Vertical asymptote at 0. Y equals 0. Clever.